Alrighty, welcome to Tag Day 12. Today we're reviewing the skill of calculating the volume of pyramids, which is 7.9a, and this will be very similar to yesterday, but we need to make sure that we know how to identify pyramids. So of the shapes below, which ones are pyramids? 1, 2, or 3? Well, I hope you only chose the first one because only the first image is a pyramid, because pyramids have one base here that I'm shading, and then at least 3 lateral sides that lead to one vertex at the top, or a apical part, which I informally call that, but that is a vertex. Okay, so the other 2 shapes are triangular prisms. So notice how they both have 2 rectangular bases that are congruent and parallel. So this is actually, 2 triangular bases. So if we look at this one, we have a triangular base here that is parallel to this triangular base, therefore it's a prism. And then we could imagine that if the top of this pencil cup is a triangle, then the bottom is also a triangle. So that's why these are not pyramids, but prisms. So 7th graders often make this mistake on STAR because it can be very tricky, so please be careful. Let's go ahead and review this problem together before we begin practicing some more problems today. So let me zoom out. A pyramid has a square base and a height of 16 meters. The edge of the base is 8 meters. What is the volume of the pyramid? So if they are looking for the volume of the pyramid, I don't actually physically see a pyramid, so let's go ahead and draw a picture first. So it says the base is a square, and so this can be a little tricky to draw the square. Sometimes I have to do little sketches like this, and then I know that the vertices, come together at a point, and then this one in the back will be a dotted line. So here is our square pyramid. And we know that the height of the pyramid is 16 meters, so draw my dotted line. Height is 16 meters, okay? And then we also know that the edge of the base is 8 meters. So if this side is 8 meters because it's a square, what do we know about the other sides? They are also 8 meters as well. So now that we have indicated this in our drawing, let's go ahead and see our reference chart for the formula for the volume of a pyramid. So I see if I look closely, volume is the section I'm looking for, and pyramid is the shape I want. So volume equals 1/3 area of the base times the height. So very similar to a prism, but we also have the 1/3. So I know that this translates to area of the base times the height times 1/3. So we can begin substituting the numbers that we have into this formula. So we know that the base shape is going to be a square because that is what they identified here in the problem. And that's how I tried to draw it as well. And so since the base is a square, how do I find the area of a square? Well, I remember that a rectangle or parallelogram also includes the square. So for big B, I need to use the base and height for our square base. And I know that the base and height of our square base is 8 meters by 8 meters. So when I substitute that and multiply, I get 64 meters squared as the area of the base. So I can now substitute that into my volume formula. And then the height of my pyramid is 16 meters tall. So I have now substituted everything I need into our formula. Okay, so now if we are going to multiply, remember we can multiply in any order, but I like dealing with the fractions first because I know multiplying by 1/3 is the same thing as dividing by 3, similar to when we multiplied by a half with a triangle formula, it was the same thing as dividing by 2. So if I see any number here that is easily divisible by 3, I could do that first. I don't necessarily see one right off the top of my head, so I'm going to multiply 64 times 16 first. Placeholder. And I get 1,024, so 1,024, okay? Well, we have one last step, which is very common to forget, and that is multiplying by 1/3, or like we said, dividing this by 3. So let's go ahead and set up my division with my seats. And I see that goes in 4. Okay, I had to zoom out a little bit because we were running out of room. 3 minus 9. I see that's a repeating decimal. So our volume is about 341.3 repeating, and our units is meters. And since this is a 3D shape, it would be cubed. So the volume is about 341.3 repeating cubic meters. So let's just stamp that when we calculate the volume of a pyramid, do not forget to always take 1/3 in the formula, right? Either multiplying by the fraction or dividing by 3. Super, super important. So when we are given a word problem, we can draw out the shape, putting the dimensions in the shape. We need to then find the area of the base using our star chart. We then need to substitute that into our volume formula and then solve. So we're going to try some more on our own.